So for today's sharing session, so we are diving into a topic that is increasingly gaining attention in our sustainable effort, which is the circular economy and waste reduction for bioenergy productions. So the today's session, we explore how this concept interconnected and why they are crucial for a sustainable future and how we as individual and also as institution can play our part. So before we got into the details of this presentation, let me highlight what are the four key objectives of this today's sharing sessions. The first objective is to understand the principle of a circular economy, which is how it differs from our traditional economic model and why it matters. The second objective, which is to explore strategies for reducing waste in a sustainable manner, not just through recycling, but also by redesigning system to eliminate waste from the start. The third objective is to discover the role of bioenergy in supporting a circular model, how this waste can be transformed into renewable energy. And the last but not least is to discuss the real world challenges that we face and the opportunity that rise from implementation of this concept. And we also look at the strategic action that can be taken at institutional and also at community level to support this shift. So the first part of this sharing session is the introduction to the circular economy. So what is circular economy is all about? So in contrast to the linear economy, which follow the path of extracting raw materials, using them to manufacture products, consuming those products, and finally discarding them. So the circular economy represent a regenerative system. So in a circular model, resources are kept in use for as long as possible. Products are designed to be reused, repaired, or recycled, and biological materials are returned to the earth to regenerate natural system. So this change in mindset from waste as an end to waste and as a resource is a powerful shift. So it encourages us to design systems that prevent pollution and support long-term environmental resilience. If we look into the key principle of the circular economy itself, so the first key principle is to design out waste and pollutions, which means we rethink on how we design products and systems so that waste and pollution are not created in the first place. And then the second key principle is keep products and material in use. In other means, we extend the life of materials through reuse, repair, remanufacture, and also recycling. And the last one is regenerate natural system. So we give back to the environment by enhancing ecosystem instead of depleting them. So these are principle guide not only companies and policymakers, but also educators and individuals towards a more sustainable and resilient economy. And then we look into the global circular economy examples. If we look into the first one, which is the EU Circular Economy Action Plan. If you look into the European Union, they has launched a Circular Economy Action Plan as part of its European Green Deal. So it promotes sustainable product design, waste reduction, and also circular business model. And then if we look into the second example, into our neighbor China, China has made a circular economy as a national priority, established circular industrial parks and integrating circular economy into legislation. And then the other one, organization like the Ellen MacArthur Foundation work with corporation to transition towards circular operation, influencing everything from packaging to logistics. So these are the examples that show that circular economy is not just a theory, it's also a practical, scalable approach being embraced at multiple levels to worldwide. So next we look into the what reduction strategies. So the first thing that we look is what is waste reduction is all about. So if we look into the definition, waste reduction is the process of minimizing waste generation by using resources more efficiently. So it's not just about managing waste after it's been created, it's about preventing it in the first place. So it can be achieved by designing products and processes that use fewer resources, last longer, and are easier to repair or to recycle. So there are many types of waste that can be seen. For example, there are industrial waste, municipal waste, agriculture waste, and also food waste. So each of these present opportunity for reduction and also for reuse purposes. So the goal is to create a circular system where waste is minimized at every stage of the product life cycle. So next, we look into the hierarchy of waste management itself. So there are 6 concepts of the zero waste: rethink, refuse, reduce, reuse, recycle, and repair. So if we look into the rethink and refuse, the most effective way to reduce waste is to avoid creating it. So this means rethinking our needs and refusing single-use products. The second one is reduce, which is minimize the material use and waste product in our daily life and production process. And the third one is reuse, which is to give products and material a second life before discarding it. The fourth concept, which is to recycle, which is to reprocess used materials into new products. Recover, which is to extract energy from the waste materials. And the last, which is to dispose, as a last resort, landfill or incinerate waste that cannot be otherwise be treated. So the next, which is we look into the waste streams that relevant to bioenergy. So if, as we know, there are many organic waste streams that are well suited for bioenergy production. These include agricultural residue, such as rice husk, palm oil waste, corn stubble, and sugarcane. So these are rich because they are rich in cellulose and lignin, and making them good feedstock for biomass energy. We also have the municipal solid waste, especially the organic fractions like food waste, garden trimmings, and also paper. The other potential waste that can be used, like food waste from home, restaurant, and markets, and also animal waste and sewer sludge, which can be treated anaerobically to produce biogas. So next is the best practice. What is the best practice in the waste reductions? So there are several practice and several practical and proven strategies to reduce the waste. The first is the source separations, which is to sort the organic waste at the point of generation, make it easier to divert it from landfill and direct it to composting or biogas systems. The second one is the anaerobic digestions, which is the process where microorganisms break down organic waste in the absence of the oxygen, producing biogas and nutrient-rich digested. And then the last one, which is decentralized composting, which is can be used at the community-based area or institutional area. The purpose is to reduce transport emission and also returning nutrient to the local soil. Next, we look into the bioenergy production. What is the bioenergy is all about? If we look into the definition of the bioenergy, so bioenergy is a renewable energy that made available from material derived from biological sources. For example, we have the biogas produced via anaerobic digestion of organic waste. So it mainly contains methane and can be used for heating, electricity, or even vehicle fuel. The second one is the bioethanol, which is made by fermenting sugars from crops like corn or sugarcane. So it's a cleaner alternative to petrol. The other one, the third one is the biodiesel, which is produced from vegetable oils, used cooking oils, or animal fat. So it is used in the diesel engines. The last one is the biomass combustions, which is the direct burning of organic material that wood chips or pellets for heat or power. So if you look into the next element, which is the feedstock for bioenergy. So bioenergy feedstocks are organic material that can be converted into usable energy. For example, you have the kitchen waste can be digested to produce biogas. We have largely our resources in palm oil mill effluent, which is the high strength wastewater with significant methane potential. And then we have the sawdust and sugarcane bagasse. So these, like no cellulosic materials, can be processed into biofuel or combusted directly. And then the current trend that we apply nowadays is the algae. So the fast growing and rich in oils and carbohydrate. This algae can be cultivated using wastewater and converted into biofuel. Also now the current trend is to transform it into hydrogens. So why bioenergy and circularity? So how it's connected? So in the circular economy, waste is not the end, but as a resource. So the conversion, for example, of ammonia into the methane and then electricity is one of the example. Waste from palm oil production is digested and anaerobically to release methane, which to use for the power generation. So this reduce fossil fuel usage and lower the environmental pollution. So this one of the model that illustrate how a circular economy can close the loop, especially in the agri-industrial sector. By adopting this model, industry can transform their waste liability into energy asset. The next part, which is quite important, is integrating circular economy and bioenergy. The first thing is to closing the loop. Closing the loop is a core concept in the circular economy, especially when applied to energy system. So instead of sending organic waste to landfill, which emit harmful methane and contribute to environmental degradations, so we convert it into usable energy. So this energy can then be fed back into the production cycle to power facility, heat homes, or fuel vehicles. So this closing the loop not only reduce dependency on fossil fuels, but also capture the value of waste materials. So in essence, waste become a resource rather than a liability, and then create a truly regenerative system. So if we look into the first case study here, so we have the biogas from food waste here. For example, practical example from the school cafeteria waste converted to biogas. So the school implemented a food waste collection system in its cafeteria. So this waste was fed into a small and aerobic digester on site, which produced biogas. So the biogas was then used as a cooking fuel in the cafeteria kitchen. So the impact was substantial. Food waste was reduced, cooking costs went down, and greenhouse gas emissions were minimized. This shows how even small institutions like a school can benefit from a simple circular economy solution. The second case study, if we look into the biomass in Sarawak itself, if we look into the Sarawak itself, we reach in natural biomass resources. Timber processing industry generates woods waste. The palm oil sector produce empty fruit bunch. Rice farming yields husk and straw. These materials can be turned into energy or into renewable energy using several processes such as the combustion, gasification, or anaerobic digestion. What exciting is the potential for rural electrification. So it's using locally sourced biomass to power off-grid communities. So the industry can also tap into these resources for energy independence, reducing reliance on centralized power and fossil fuels. So the next is the enablers. What is the enablers in order for us to shift from the linear economy to the circular economy here? So if you look into the technological enablers here, So technological advancement are making circular bioenergy system more feasible. So here are the some of the few key technologies that can be implemented. The first is anaerobic digestion units, which is available in various scales from household to industrial. So we have also microbial electrolysis cells, which is a cutting edge technology that convert economic matter into hydrogens. For MEC is a current trend nowadays, how the system can be used in order to treat organic waste to be turned into the hydrogen production. And then we have the gasification reactors, which is to convert biomass into syngas, which can be used to generate electricity or produce fuels. So on the digital side, if you look into the digital side, there are a lot of smart sensors that can help or they can assist the system to monitor waste stream and optimize energy output. So blockchain technology can also be used to track the life cycle of waste, adding transparency and traceability. In order for us to move into the circular economy, to shift from the what we call that, the conventional linear economy to the circular economy, there are challenges and opportunities as well. If we look into the challenges, one of the potential challenges here is the infrastructures, because if we look into the technology itself, there are a lot of technologies, there are a lot of systems that has been introduced. So but in terms of the infrastructure itself, there are still lack proper system for waste collection, segregation, and also the treatment. And then the second challenges, if you look into the second challenges, is the cost itself. So the initial investment in bioenergy system is somehow is quite high, especially those for small communities or for the small size business. And then if we look into the policy enforcement itself, so the regulation might exist, but still without proper enforcement. So the progress is quite, we can say that's quite limited. And then the public mindset itself, people may be unaware of the benefit or reluctant to adopt new behavior. So awareness and education campaigns still need to be conducted. So beside of the challenges that we are facing nowadays, so we also have the opportunity when what we call that, when we shift our economy from the linear economy to the circular economy for this type of bioenergy system. The first thing that we look into is the green jobs. The green job meaning that there are a lot of potential new employment in bioenergy, waste management, and sustainable agriculture. There are a lot of careers can be created. There are a lot of job opportunities for the youth. There are a lot of job opportunity for the graduates and so on. Income generation. Waste become a resource generating revenue from compost, biofuel, or carbon credits. So nowadays, waste is no more like people just throw it away to the drain and also to the landfill. So now people now need to think how this waste can be part of their income. For example, if they have agriculture areas, they have the farming areas. So instead of burning out their waste, now they can turn their waste into income generation, where the third parties can buy their waste and turn into other potential products. And then energy access. When we use the circular economy itself, we are not limit ourselves to be connected to the power grid. So we can create our circular economy system at our rural area, and from the waste we can process it to turn into the energy. And then it will boost the startup and researcher to come up with a new potential solution to support this circular economy concept for this bioenergy. So what institution can do? First is like UNIMAS itself. UNIMAS itself, we really support the Green Campus initiative. So we are now, what we call that, promoting the low carbon campus concept, where we really educate, we really advocate our community campus to recycle whatever waste that we generate from our daily activities. And also we really look into how this waste can be generated, can be used to generate other type of energy. Instead of that, we also looking into how we can recycle back whatever material that we have, and then to be reused for other purposes and can be turned into the income for the community. And then if we look into the pilot circular economy bioenergy projects in labs and also in cafeterias, where we really urge the the owner of the cafeterias don't throw away their cooking oil. Instead of throw away their cooking oil in the drain that we polluted the environment, so we can help them to recycle back or reprocess back the used cooking oil to be turned into the other type of product like biodiesel and so on. And then that's the role of the institution. Us as a community, what we can do as a community, because community we can consider as the heart of the circular system. Simple action by the community like setting up the household compost bins or segregating kitchen waste can have a big impact, because it will ease the process later on how the third party can identify and re-strategize back the waste to be turned into the biogas or biofuel. And then the last one is the vision for Sarawak 2030, alignment with PCDS 2030. So all these efforts in terms of the circular economy is actually aligned with our PCDS 2030, where this PCDS really promote green economy, sustainable energy, and resilient communities. So to conclude my sharing session today, to summarize, we can say that circular economy really help us to rethink and redesign our system. The main purpose is to eliminate the waste. And then bioenergy is the product that we can think of when generated from the waste, and to allow us to recover value from organic material, which is to turning waste into a renewable resources. I think that's all for me. Thank you.
All right. Thank you, Dr. Farid, for the short and sweet presentation and very introductory. So now we'll have a short Q&A session. If any of you have any questions, you can feel free to type it in the chat. But in the meantime, while waiting for more questions, maybe I can start first. So just now, I think there's the mention of regenerating as part of the circular economy, right? Or regenerate. So maybe you can share some examples on how it is being implemented or could be applied in our local context. Because I think regenerate is something that we don't hear often when we talk about the 3Rs and all that. Yes.
For example, the common is our used cooking oil itself lah. Our used cooking oil itself. I think there are a lot used cooking oil from the community areas. But the thing is, community is not being exposed on how this cooking oil need to be processed. If you look into the European people, developed countries, they know, and then they've been exposed on how this cooking oil is processed to be turned into the biodiesel. That's why in some countries like France, Germany, and so on, their farmers reuse back their used cooking oil and process it back, and then they use for their own generator, for their own tractors. This some of the example that I think community in Malaysia has not been exposed to some extent of the process. So there are certain things that we can think of. For example, uh, the use the wastewater and so on. How this wastewater can be turned into income for certain communities. And then the other thing is uh, like my colleague are doing is for the rural area, I think in Long Lamai, how they can turn the waste into the biochar. Instead of throwing away the waste to the environment, they need to segregate it and process it or incinerate it. And then when it's already incinerated, so it can be can be transformed into biochar where it can be used to treat the water for the daily activities. So these are the thing that the simple thing or the low cost activities that can be applied to 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 implement this circular economy.
Okay. All right. And also just now, I think we also look into the different types of waste that you have shared. So in your view, which waste stream would be the biggest challenge, currently presents the biggest challenge for Sarawak, and what opportunities do you see if we address it?
I think the issue here is what I've been discussed with my stakeholder before. The issue in Malaysia and also globally, we have the technology to convert the waste, for example, the agriculture waste into biofuel, into the biogas, into the hydrogens. The issue here is how we can sustain the feedstocks. Who become the main supplier of the feedstocks? Because we are talking about the output, but we forgot to think about the feedstock, the sustainability, how to sustain the feedstock. Maybe today we have 1 ton of the organic waste, but how about next month? How about the following months? Can we predict that we can still maintain the same quantity of the feedstocks to achieve the same output that have been designed? I think these are still the current challenges that we are facing nowadays, regardless the type of waste. Because if you read the journal, if you read the technology that been proposed, been developed by the companies, I think there are a lot of the technology itself that have been developed to turn the biomass into the bioenergy. But the issue here is how we can sustain the feedstock. The feedstock is now still the question for us. For example, if you want to have bioenergy for certain quantity, and then how we can ensure that we still can maintain the same quantity of feedstock for the subsequent months or subsequent year.
Okay, interesting on that. Okay, all right. So another one is on the bioenergy, because I think there's quite a few, right, on like biogas, bioethanol, and the biodiesel. So which sectors or communities could benefit the most if from their adoption, or how this bioenergy can be used?
I think the community they are using the what you call that agriculture type of communities. I think is the most benefited if they really want to go for this biofuel and so on, because the source of the feedstock is come from their own agriculture waste. So now, like I mentioned just now, is no more. I think the technological advancement is already there, but the educational part need to be implemented, because of most of the farmers or most of the agriculture's player still not been exposed to what type of simple processes that can help them to convert their waste into the biofuel. And then they are still lacking of the technical skill in terms of completing them lah.
Mhm. Okay. So let's say like for the biogas and all that, like, who would actually be the one that is going to use them along the line later?
I think there are a lot of there are a lot of users at the end of the day. For
Mhm.
example, they also can sell it to the nearby industries, because
Mhm.
industries also use a lot of gas, a lot of fuels, and so on. And with the current trend nowadays, where the national agenda is to achieve the carbon neutrality by 2050. I think by implementing this biofuel, biogas, and whatever biogas, I
Mhm.
think it will help to achieve the carbon neutrality by 2050. Because whatever we create, then whatever waste we create, then we need to reuse and we need to reshape into other type of products.
Okay. All right. I think that's about it. I think there's not much questions, not any questions from our participants as well. So if that's the case, maybe we can have a quick group photo first for everyone who could
Okay,
turn on your cameras. Yeah. Just give everyone a minute to turn on your cameras. So in the meantime, also please stay tuned to our social medias for updates on our next session for the month. And also take a moment to fill out the feedback form which has been shared in the chat. So I'll just take a quick one, no worries. 2, 3. Okay, no problem. Okay, all right. So if that's the case, then I think that's all for our sharing today. Thank you once again to Dr. Farid and our
yep.
supporting partners, and have a good day.
Okay,
Thank
thank
you.
you. Yeah, bye.